Alright, Texas Math Mundo audience. Today is an instructional video and the topic is angle of elevation, sometimes called angle of inclination, and angle of depression, sometimes called angle of declination problems. You'll see them several times on the UIL contest. Alright, let me take a quick moment and ask you that if you enjoyed this channel and you enjoy the content of this channel, please hit the subscription button and the notification bell. That really helps out my channel and I would really appreciate it. Also, smash that like button and leave a comment below. Angle of depression, angle of elevation problems are right ahead. My name is Saul Cantu and this is Texas Math Mundo. Texas Math Mundo audience. Today's topic is solving angle of elevation, sometimes called angle of inclination, and angle of depression, sometimes called angle of declination problems. There are three fundamental ideas here to get started that you must have command of if you're going to solve these problems. First, you must have command of your basic right triangle trigonometry. That is the sine, cosine, and tangent functions in the context of a right triangle. Second, once you're starting out solving, I would draw a picture. Now in the math contest, time is of the essence. So as soon as you get comfortable with these ideas, then you can omit the picture. But to begin with, as you're getting these ideas straight, to make sure everything's in order, I would draw the picture. Just to begin with, again, time is of the essence on the math contest. And so you may want to omit the picture because of time. And third, you must understand that angle of depression and angle of inclination problems, angle of elevation and angle of depression problems are always from the horizontal. So your angle of elevation is upward from the horizontal and your angle of depression is downward from the horizontal. With these three foundational fundamental ideas, you should be able to solve any angle of depression and angle of elevation problems. I'm about to do a couple problems as examples. So we have before us, we have the 2018 District number 40 problem. And this is an excellent example of angle of depression and angle of elevation problems. In fact, you get 2 for 1 on this problem. That's why I've decided to do it. So let's go ahead and read the problem. Jose, can you see? Typical Larry White humor. That's funny. Jose, can you see, is standing from the base of a flagpole. The angle of depression from his eyes to the base of the pole is 16 degrees. The angle of elevation from his eyes to the top of the pole is 60 degrees. What is the height of the flagpole? So in this case, I'll draw a basic stick figure. When they handed out art skills, I was last in line. So here goes my stick figure, kind of. Jose right there. You got a flagpole. And it says, so remember, it's always from the horizontal. So I'm drawing Jose's eyesight to the flagpole. And it says the angle of depression from his eyes to the base is 16 degrees. So right here, I have 16 degrees. And it says the angle of elevation from his eyes to the top of the pole is 60 degrees. So I should probably draw that higher. And you have 60 degrees. Of course, this is not to scale. It says, what is the height of the flagpole? So for this problem, we got both. We got an angle of elevation and an angle of depression problem. Now, important, it says it's 20 feet from the flagpole. So this is 20 feet. So we're going to get two problems. We're going to get x sub 1, x sub 2, and when we add them together, we'll get the height of our flagpole. So dealing with the angle of elevation, what we got is we got a right triangle right here. We have the parts we have is we have the adjacent to the 60 degree angle and we have the opposite. So to set up for x1, we know that the tangent of 60 degrees has got to equal to the opposite over adjacent, x1 over 20. And so that implies that x1, or this upper length of the flagpole from its eyes to the top, is equal to 20 times the tangent of 60. All right, and for the angle of depression section, maybe I'll use a different color here. To find an x2, we have another right triangle. Again, we have the adjacent and the opposite, so you know that the tangent of 16 degrees is equal to the opposite, which in this case is x2 over the adjacent, and that implies that the lower portion of the flag, from his eyesight down, x2 is equal to 20 times the tangent of 16 in this case. All right, so we break out our calculator and we do the calculations. We have to solve, we got to make sure we're in degree mode. And so right now all I got to do is tap on that radian button, make it degree mode. Once I'm in degree mode, it's a simple calculation. And let's add them up to get the height of our flagpole. That one, enter, plus, let me get the 34.61, enter, and we end up with, and let me get the approximation, 40.3759, and to the nearest foot, it would be 40 feet. So 40.3579, and to the nearest feet, that would be answer C. All right, cool. So this was a cool, unique problem. We had both an angle of elevation and angle of depression in the same problem. So it was a good problem to illustrate the point. All right, so next. All right, so our next problem is 2018 UIL B number 40. Let's read the problem. It says, I see it, some more Larry White humor. I see it spotted a plane flying over his house. He noted the angle of elevation from him to the plane was 32 degrees and 40 minutes, and he was 1,530 meters from his house. Using this information, IC was able to determine the altitude of the plane. What was the altitude of the plane to this nearest meter? So let's go ahead and draw a picture. Let's say he's this small stick figure right here. He got the plane up on the sky here. Plane, not a very good looking plane, but it'll have to do. And it said he knew what the angle of elevation from him to the plane was. So I'm going to draw the horizontal, the plane, and the angle of elevation here was 32 degrees and 40 minutes. And it says that he was 1,530 meters from his house. So the plane's above his house. So IC spotted a plane flying over his house. He knew the angle of elevation from him to the plane was 32 degrees, 40 minutes, and he was 1,530 meters from his house. Using this information, IC was able to determine the altitude of the plane. What's the altitude? Okay, so we got a right triangle here. We have the adjacent side, and we're searching for the altitude, which we'll call X. So, opposite over the adjacent, we know that the tangent of 32, now we want to be in degrees here, so what I'm going to do is I'm going to change it to 32 plus 40 over 60th of a degree, because there's 40 minutes in a degree, is equal to the opposite over the adjacent. And then and then when we solve, you can go ahead and say that X is equal to 1,530 times the tangent, and I'll just call that 32 2/3 of a degree. And so let's put this into the calculator. And our answer is that it's an exact mode. So to get the approximation, I'll put Control Enter. And we have an altitude of 980.986 meters. 980.986 meters. And to the nearest meter, that is C. 981 meters. All right, so that's a classic example of an angle of elevation problem. All right, so next problem. I'm going to leave it to you as an exercise. What I'll do is I'll display the problem, and then I'll ask you to hit the pause button. And what will happen is I'll then display the work completed and the answer, and you can check yourself. That's the idea. Okay. All right. Our final problem is from the year 2020, the UIL B release, number 43. It says the angle of inclination from the top of Sid Up's house to the top of High Up's cell tower is 18 degrees. And the angle of depression to the base of the tower is 25 degrees. How tall is High Towers if it is 150 meters from Sid's house? All right, so there we go. Angle of inclination, which means angle of elevation. And we have it, and so there you go. I'm going to give you a chance to pause, to do the work, and then what will happen is I'll come back with the work completely shown so you can check your work against mine, and we can see what the correct answer is. Okay, you can pause it now if you'd like. All right, and so here is the solution. It's very similar to the very first problem we did. We set up the two triangles. We have an angle of inclination. We have an angle of declination. We add them up to get how tall High Tower is, how tall the tower is. All right, so there you go. I hope this proved useful to you. All right, I hope you enjoyed that instructional series. I have plenty more ahead. There's plenty of math to talk about. I'm going to take a moment, please, and ask you that if you would, please hit the subscription button and the notification bell. That really helps my channel a lot if you'd like to support it. Also, smash that like button. That also helps the channel. And leave a comment below. I really appreciate your support. There's plenty of great stuff ahead of us. Thanks very much. My name is Saul Cantu, and this is Texas Math Mundo. Farewell.